Right, our last speaker of the day is Joyati Debnath from Winona State University, speaking to us today on measure theory for undergraduates via IBL.
Well, thank you very much for being here. I know it's a last presentation of the day, and I'm very happy that you are here. I will quickly tell you how it's kind of like a story that how I used this method for my classes and how it all I was successful doing it. So basically, this is my university. So the philosophy that I used for this class was these two things: that the student is taught the best who is told the least. And the other one was I hear, I forget, and I see, I remember, and I do, I understand. So students understand more when they do something. So IBL and Moore Method kind of making my mindset said what I was planning to do and how I'm going to handle this. So it's a deductive manner of instruction used in advanced mathematics courses. And the content of the course is usually presented a whole or in part by the students themselves. Students are given a list of definitions and theorems which they are to prove and present in class. And I will go over each one of these. Limits the amount of material that a class is able to cover. This is always the case. But it also induces a depth of understanding that listening to lecture actually cannot do. So there are lots of benefits. Benefits of this method is it teaches problem solving skills, critical thinking skills, and also in many different disciplinary content. We heard different people talking about that. It promotes the transfer of concepts to new problem concepts. It teaches students how to learn and builds a self-directed learning skills. We talked about confidence building. It also develops students' ownership in their inquiry and enhances student interest in the subject matter. So those are the important things that I was looking for doing this. So the steps that I thought I will be focusing on, and I have been coming to this conference for last 4 years, counting this year. And at the very first time I came, listening to everything, I felt like, oh, can I do it? Can I do it? I see a lot of people who are teaching, who will be teaching first time in fall or in the spring. I hear their skepticism in their mind, how they will be able to handle it. It was the same kind of situation for me. So I kind of wanted to put in very specific way so that I get more focused what I want to do. So the steps that I wanted to use for myself, that first is, first I should know what the student's background, where they're coming from. And then if I can build on their background. And then I wanted to see, instead of them passively listening to me, can I create some kind of inquiry within them? And finally, how they can justify and document and also present to share their learning. Okay, a quick way of telling you where I'm coming from. I'm Winona State University. It's in Minnesota, and that's where in the map. These are the pictures of different seasons, so just to let you know where my campus is. And this is the composition of the department, so you get a bigger picture of how it can be done. So this is a joint department with math ed, and statistics program. This is how the faculty compositions are. We do hire fixed term and adjunct every semester. We have about 100 to 120 majors in the department. When I say in the department, this count for math ed, and stat. And there are several joint majors with physics, engineering, and computer science, psychology, and music. And then for a long time, we had a math major, but all majors had to have a joint major or a minor. So just very recently, we worked on just a standalone major, and we now have more courses, deeper mathematics courses that we are able to teach. So out of all these 100, 120 majors in the department, about 15 and 20 are actually the math majors, and about 7 or so almost every semester kind of heads for graduate school. In this new math major that we created, we had two choices that students can do, which is for advanced study. One is Advanced Calculus 2 after their Advanced Calculus 1, and then Abstract Algebra 2 after Abstract Algebra 1. So they are supposed to choose one. So Advanced Calculus 2 was only first time it's offered with 5 students just last semester, spring 2002. And since I am kind of leading this group with making a new major and curriculum development, it just happened that it got on my shoulder to teach this for the first time as an undergraduate level. So I started looking at where the Advanced Calculus 1 material left off and how I can build this idea and do the next course. So these are the reference books that I thought I will let the students know. The first one, Advanced Fundamental Ideas of Analysis by Michael Reed. This was their textbook for Advanced Calculus 1. So I exactly knew what they have done in that course and what they have known. And then the second one that I was thinking of using, but I really didn't use it, I use it as a reference, is the Measure, Integral, and Probability. If you teach Real Analysis 2 and you concentrate on measure theory, you will notice there is no such undergraduate level book for this kind of material. And so there is a gap. So you have to kind of use graduate level book and kind of see how your undergraduate student can understand or be able to follow what you are doing. So the material that I kind of separated the material in three big portions. One is sequences and series of functions. That's where we need to start after Advanced Calculus 1, and then some amount of metric spaces, and finally the measure theory. So I did all of this using this Moore IBL method, but measure theory is what I want to talk to you about. Okay, so in this course we had about 5 students, which they are all graduating seniors, and I had 3 males and 2 females. All did either 1 or 2 RUs in their time when they are in the university. They have also done some research interns, and all have attended either 1 or more math conferences, either Pi mu Epsilon or MathFest or joint math meetings. And they are all equally involved in different mathematical activities within the department. So this is the first step. This is the first step about knowing your student, what they have known, especially in mathematical world, and how they have functioned so far. Okay? And so the next is, like I was talking about, going back to the steps, assessing prior student knowledge. So this was done. This is how I found out, okay, where are they coming from? Should I use this method? Will I be successful? The second thing is building on background knowledge. This is the big part. This is the one that I wanted to do. And developing the inquiry. Well, since some of these, almost all 5 students have RU experience, that they have gone to other campuses and did RU, so I assume they have this kind of inquiry skills. And they also presented. So justify, document, and share, I said, okay, they have some experience. Developing the inquiry, they have some experience. So this will not be really making them shaky about, okay, what is Joyati going to do to us? Okay, so now I'm trying to build on their background knowledge. So I started with the preliminaries, and then I started to develop this inquiry through this background knowledge, and we talked about Riemann integral, and then I started asking what are the scope and limitations of the Riemann integral. Okay, this is where student had to start talking. Student had to explain it to me or to others that, okay, can they prove Riemann criterion? So now I am giving them what Riemann criterion is and kind of reviewed, and I said, okay, you need to start thinking about proof. But because they have some experience before, they're working on it. Okay, the next question that I put is, can continuity requirement be relaxed? Okay, so if they are thinking, no, it has to be in the closed interval, it has to be continuous. Okay, what about this kind of function? So I gave them this kind of examples, and then asked them what they think about this. Then can they prove f of x equal to radical x? Is this Riemann integrable? So I'm looking at how they handle the square root. So will they do the partition using the squares? What about this kind of interval where they either have a discontinuity or they have improper integral with the intervals? So I asked them about how this whole idea depends on the intervals, about the functions. What about if we just construct functions on general sets instead of intervals? So this is going on. It takes like few weeks to get to these kind of situations. Finally, the next inquiry was what about the completeness issue? Okay, I asked them to investigate whether the limit, in some sense, of a sequence of Riemann integrable function is also Riemann integrable. What fails? What works? Why didn't it work? Okay, and so give or create examples. So students will have to give me examples or create or develop in the class. How does the idea of convergence can be revised in order to make this integration happen? How do we measure the distance between the functions? So what are the ways that you can decide you are going to use L1 norm, sup norm, what are you using? And okay. Okay, so then after kind of getting through this, it takes about 2 to 3 weeks. Finally, okay, so then the need of Lebesgue integral, why this is needed, what can this do to make things work? So then we define measurable functions, and then we want to compare and connect Riemann and Lebesgue integral and discuss the previously given examples where they have a limit of Riemann integrable functions, but that was not Riemann integrable. But now can we construct that some idea, some theorem where it can happen? So what about the functions like this? Now this kind of function. What about functions sin x over x? You know, what can that be extended? So then I want them to prove the limit almost define almost everywhere. So what about prove that the limit of a sequence of measurable functions is measurable? So we talked about that then. Now the next part is developing the inquiry. So making students to think that the obvious things are not always true is difficult. Uncountable sets can be null. Okay, once you give this the definition, and then choose ask them, okay, well, if you have that many points, how can that be null? Prove that the Cantor set is uncountable. Why is Cantor set can be null? Okay, and then we talk about Lebesgue function and ask them to define and sketch and learn more about Devil's staircase. And this really got students very, very excited. And students just jumped up on that. And we even talked about how math department can have that kind of staircase. Okay, so this is my third, last part, where now students have to justify, document, and share, the fourth step. So this is my observation, and I would definitely ask you to try this kind of thing in your class, but you have to know your student, you have to know the number of people in your class. So first, the students, when I give them work to do, right away the student will start working on them or picturing them or drawing pictures, and I will walk around them. Once that student kind of did that, second, they started little conversation with the person they're sitting with. Okay, and they said, what did you get? You know, this is, okay. And then they started looking at, they will turn around, and 2 people are sitting there, 2 people are sitting here. They'll turn around, okay, what did you get? And they will talk about with the other pairs. Finally, everybody is now talking to each other. Somebody's talking from there, you know, everybody's talking. And then these students, since these students, like I told you already, they have already done RU. One student will just get tired of writing things on their paper and showing, okay, they go to the board and then they start writing on the board, and then they will tell each other, and then somebody else will come. And I'm kind of sitting over there, kind of watching what they're doing, and once, you know, to make the conversation going, I'm throwing things at them. Okay, you know, didn't you hear what she's asking? Did you understand what he's asking? You know, it's kind of like that is what I did. Okay, so now you will be asking me, okay, Joyati, how did you do the grading? This is always a question about how to do the grading. This is the kind of way I started doing the grading. As you can see, attendance, classwork, and participation, and I kind of took notes of who is participating in what level, presentation, and they always had to have some homework. And the students said this was a great course, you know, this was best class ever. They learned most learned than any many others. So these were kind of a nice thing to hear. These are the references that I use if you want to do this course or this kind of course. For my lecture, I prepared myself reading those two articles, the articles that I have at the top. And this also helped me to understand how this can be transferred from kind of lower level on. This is really fun. If you get a chance to see this, it has a lot of fun things that you can bring it to the class and have them energize the level of excitement. This is really good. That's really all I have to say. And any question? Thank you.
Any questions?
Well, it is a question. One of the things, have you heard of the Hinstock integral or the McShane integral? Yeah, generalized Riemann.
Okay.
That
will help?
I can't say that I've followed this all the way through, but you can develop measure theory by looking at the characteristic set.
Okay.
Say of the McShane integral, or they're not equivalent. The McShane integral, I think, is actually equivalent to Lebesgue integral.
Okay.
And they're Riemann style integrals. You don't have to have any measure theory to develop the McShane integral. Just something to think about.
Right. That will be very good. But they wanted that I do measure theory. This was directed from the department that we want to give them some idea on measure theory because these people are going to go graduate school. So entering the measure theory through Riemann integral and Lebesgue integral was, I thought, my only choice because of the level.
In other words, they wanted you to develop measure theory in a particular way.
Yes.
Because you can, through the Hinstock and McShane integral, develop measure theory.
Okay, I see.
It's just not the standard traditional way.
Right.
Which that's probably one of the reasons I haven't followed it all the way to the end, because I know that there's a certain style that people are looking for.
Okay.
And I hate to put my students at a disadvantage, but it's something to think about.
Okay, so it's called Shane interval?
McShane.
McShane, okay. That's awesome.
Or Hinstock, look at IJ McShane, is it EJ or IJ? McShane integral, if you just Google McShane integral. And the Hinstock integral, you can find it. Or if you email me, I can probably send you some references.
Great, thank you.
Look up generalized.
Yes, okay.
Any other questions or comments?
Well, comment, those non-standard integrals have bad properties. So that's the main reason people kind of dislike them. The Hinstock integral is not translation invariant. So, I mean, this is so counterintuitive a way to build measure theory.
So my students will just blow up?
It's possible.
It's possible. Well, when I do it next time, I'll definitely look into those ideas.
Yeah, the McShane I haven't heard of, so I'm interested in finding out what that is.
No questions? Let's thank our speaker again.
Thank you.